All right, we're back, and in this one, we're going to be doing a little bit of coding. We'll code something called PasswordCreator, and that'll lead us into a discussion about the equals method and indexOf, a different method, and hopefully we'll hit this recap in this video. So, websites and applications often ask you to re-enter your password when creating an account. We're going to write a program that prompts the user to enter a password, then ask the user to re-enter the password. Then we'll print a message indicating if the two passwords match or not. Passwords should be at least 6 characters long. We'll worry about this length thing kind of after the fact. So I'm going to hop over to IntelliJ, and I need to create a new project by going to File, New Project. All right, I'll go next. Come on, computer. All right. I'm currently in my CSA folder, so I'm going to swap to my CSP, but you can probably go ahead and name your project. I'm going to go with PasswordCreator. I'm going to ensure that I have that subfolder to help me stay organized. It's going to ask me, do I want to create that folder? Of course. And this window is fine. I'm going to expand my project folder. Right click on the SRC, and let's make a new Java class called PasswordCreator. Right, we're going to go ahead and plug in our main method. A little sluggish today. And in order for us to do this, all right, we're going to prompt the user. We got to get input from the user. We need scanner. I'm going to jump straight to step 2 of scanner, which is create my scanner object. I'm going to start to type out scanner, and I'm going to let the IntelliSense auto import for me. Right, so step 1 is we import scanner. Step 2, we're going to finish creating this object. I'm creating a scanner, which I'll call input, and it is a new scanner that reads from system.in, the keyboard. Okay, we're going to prompt the user. We're going to say something like, please enter a password. I really like using just a normal print statement instead of a print line in these cases. That way, whatever the user enters is going to show up next to this prompt. However, whenever they enter that, we need to actually capture it. And keep in mind, what we're getting here is text. It's a string. So I'm going to say string pass or password is going to be input, the scanner, dot next or next line. If we just do next, we're going to get the next token. That is everything up to a space. If we do next line, it'll be the entire line. I'm going to go with next here, but I would maybe leave a comment. Input.nextLine would get the entire line. Next is only going to get the next token, that is everything up to a space. Why don't I just go ahead, and I've demonstrated this in a past video before, but I'll show you what I mean real fast. I'm going to right click in free space and tell my program to run. All we're doing so far is using scanner. We're going to prompt the user. We're going to get input from them, but right now I'm using next, which means if I come in here and say this is my password, take a moment, what do you think is actually stored in pass? Just this, right? Because I'm using next, we're going to get everything up to the space. That's what next is. We're getting the next token. If we used next line instead, we would get all of this. Now, passwords don't typically contain spaces, so I'm okay with this. I'm okay with using next here. But we're getting a password from the user. We're storing it into pass. I need to basically ask them to re-enter their password. Why don't I use this out that I got right here? We'll say something like, please re-enter the password. And again, I want to use a print, right? Because we used a print, the user's input actually showed up on the same line behind the colon. I really like the look of that. We're prompting them again. Notice I'm not recreating the scanner. That's because I can reuse the same scanner. I'm going to create a separate string variable, which I'm calling check. Right? We're going to compare pass to check ultimately to see if they are the same. And that is, just like the line above, going to be input.next. Again, notice that I created the scanner one time on line 7. It still exists. Here I'm going to tell it to get the next token, which in theory is going to be pass. Here I'm telling it the next token, which in theory is going to be check. So we should have basically both entries at this point. I need to compare them to make sure they are the same. What we're going to end up doing is basically using a loop and compare character to character. Right? If I enter a password pass 1234, right, and we'll say this is the value of pass. And then I come in here with check, and it's going to have the value, hopefully, of pass 1234. What I'm going to do is basically loop through one of these. And I'm going to ask, are these two characters the same? Are these two characters the same? Are these two characters the same? Right? In the event that we come across characters that aren't the same, right, we're going to say, are these the same? 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 We would get to this point and see that these two characters are different, at which point we would know that our passwords are different. So the moment that we find basically stuff that's not the same, we can essentially stop there. Okay? So what I would kind of do here is let's create a Boolean. We'll call it equal, and then we'll assume that the passwords are equal. We want to start out assuming that they're the exact same. The moment I come across characters that are not the same, I'm going to change the value of equal, and I'm not going to change it back. This is going to require a loop to do. So I'll say for integer I is equal to 0, because the first index in our string is 0, as long as I is less than pass.length I++. Okay? With each iteration, I'm going to ask, is the current character from pass the same as the current character from check? Okay, if pass.charat_i is equal to pass, the other string, which is check.charat, the exact same index. More importantly, I want to know, are they not equal? Because that is when I'm actually changing. If pass_charat_i is not the same as check_charat_i, then I have differing characters, and I'm going to change the value of equal to false. And that's essentially it. It looks like this for loop has two statements in it, but the only statement that's actually in the for loop is this if statement. So I'm going to get rid of the braces. The only statement that's in this if statement is this one, which we change the value of equal. So the moment that I find differing characters, I change equal from true to false. And it never goes back. Notice there's nothing that ever changes it back to true inside of this loop. Okay? If I manage to go through the entire length and this never triggers, well, it still has that value of true. Let's see what that value is. We'll maybe print off some type of if statement at the end where we change our final output statement. If equal is true, I'm going to maybe print something to that effect. Passwords are the same. Else, try again. Passwords are different. Let's try this out. I'm going to right click and free space, tell it to run. I could just hit the play button, and it's going to execute this. Please enter a password. Pass 1234. Please re-enter a password. Pass 1234. Passwords are the same, which means we got to this point and equal is true, which, by the way, equal is a Boolean value, a Boolean variable, I should say. So I don't actually have to test it against the true or false value. I could just use the value that is there. If equal is true, we will enter the body and do this. If equal is false, we'll skip over it, hit the else, and do this instead. Let's try a false case. Pass 1 2 3. Pass just 4 5 6. There we see our passwords are different. All right, I'm going to show you an interesting test case. What if we did something like pass 1 2 3 4, pass 1 2 3? Okay, why is this interesting? Well, they have differing lengths. And you notice that we end up getting a string index out of bounds. Why is that? It actually tells us right here 7. I tried to access an index of 7 and was out of bounds. Well, if I look at what is pass, right? This is the value of pass. We have index 0, 1, 2, 3, 4, 5, 6, 7. So it's not that. Here we got 1, 2, 3, 4, 5, 6. Wait, sorry, 0, 1, 2, 3, 4, 5, 6. There is no 7 in my check string, which is where the index out of bounds is occurring. Why is that? Our loop ultimately is based on pass.length, right? And in this test case here, this example, pass is actually longer than check, which means I go just a bit too far, right? On the final iteration of this, I'm trying to get the character at index 7 from pass. That's easy. It's a 4. Right here, I'm trying to get the character at index 7 from check. That's out of bounds. So this is where we're getting our index out of bounds. Okay. How would I prevent it here in this particular case? Well, in the case of passwords, if the passwords are not the same length, then of course they're not going to be the same. So before I check to see are they the same, do they have the exact same characters, I would check the length. I would only do this part if they had the same length. What do I mean? If pass.length is equal to check.length, then I would do this. There's no braces here, but this is technically only one statement inside of this if statement. If they have the same length, then I'll check to see if they have the same characters. Otherwise, if I hit this else, it means they have different lengths. We can set equal to false here. Okay, I'm going to run this. We'll see that it works, and I will show you a different approach that I would actually take, and then a actual difference that I would take. So what if we did pass 1 2 3 4, pass 1 2 3. I'm going to assume there's something up with my braces. Yes, this else is associated with this if. Brutal. All right, let's put some braces around this. There we go. Okay. Without the braces, this else was associated with this if, which this is not the route I would go anyway, but the idea is intact. If they have the same length, we'll check to see are the characters the same in the same spots. Otherwise, they must have different lengths, and so they aren't equal. So this check towards length, I would actually do it up here. Right? So how I would actually do it right here at this spot that's equal, right? So pass.length equal to check.length. Okay, what's going on? What am I doing? Right away, I'm going to ask, do they have the same length? The value of equal is going to be whatever the value of this equals relational operator is. If they have the same length, equal starts out as true. Okay? If they do not have the same length, equal is going to start out as false. How does this change things? Well, when I get down to this if statement, what I would do is say if equal. Okay, how does this help me? Well, this means I actually don't need lines 19 and 20. Let's take a look at this. If they have the same length, I'm going to get a true value here. That will be the value of equal. At which point I would get down here, see that equal still has a value of true. So we would then check to see, do they have the same characters in the same spots? If I get down here and equal is still true, that means that they have the same length, and we never ended up changing it. So they have the same characters in the same spot. If I get down here and we got a false value, it's possible that they had different lengths to begin with, or we looped through and found out that they had different characters in different spots. So this is a little bit cleaner, and it will avoid the error that I had earlier with the braces. So let me demonstrate. Pass 1, 2, 3, 4. Pass 1, 2, 3. Passwords are different. They sure are. Notice we don't get an index out of bounds. That's important, right? We're only doing this if they have the same lengths. Pass 1, 2, 3. Pass 1, 2, 3. An important test case I would do is what if check is longer? Pass 1, 2, 3. Pass 1, 2, 3, 4. They're different. So this looks pretty good. It appears to be working, okay? One thing it does say is that passwords should be at least 6 characters long. How can we check that? Well, the moment that I get the password from the user, I can validate it. I can check to see the length, okay? Look at the code. What is the moment that we get the original password from the user? That happens right here. So as soon as line 10, I can actually validate it. And I'm only going to validate this one. You could just easily copy and paste the concept and do it for check. But realities are, as long as I validate this one, it doesn't matter if this one doesn't have the same length because we end up doing it here, right? It doesn't matter if this one is less than 6 characters long because we then check the length here. So a password won't work if it is less than 6 characters long. Now, modern day passwords, that's up to 8 due to kind of encryption, right? We actually want to make a password very hard to crack via brute force. And by adding more characters, you actually substantially add the amount of time it takes to brute force a password. Anyway, I'm going to validate it here. Basically, while it is too short, how do I know that the password is too short? Well, its length, in this case, is less than 6. While pass.length is less than 6, I'm going to tell them that the password is too short. And then I'm going to basically repeat these lines. Right? I'm going to ask for the password and then try to save it in. Now, as soon as I paste that, I get an error here. If we scroll over it, what does IntelliJ tell us? Variable pass is already defined in the scope. I want to reassign a new value to pass. I don't want to redeclare the variable. By giving it a data type, we're trying to create a variable called pass, but pass already exists. So I just need to get rid of the data type. So here's the logic. We get the pass from the user. If it is less than 6, we'll tell them it's too short. We'll ask them to enter the password. We'll get the new password. That would be the end of the iteration. We would come back up and check the length again. If they gave us one that's too short again, we would do it all over again. This will keep repeating until they give us one that is at least 6 characters long. Let me show that to you. I'm going to tell it to run. We're going to have, how about pass 1? Pass is too short. Please re-enter the password. Pass 2. Still too short. The moment that I enter at least 6 characters, it asks for me to re-enter the password. We're now at this point. Okay. You could validate check to make sure it is at least 6, but there's really no reason to. As long as passes a valid length, we'll do a check here and figure it out. All right. So what we just wrote, this little section here, where we see are the strings the same, that basically already exists. It is a method called equals. The string method equals returns true if this string is equal to the specified string, false otherwise. For 2 strings to be equal, they must consist of the same characters in the same order. Here we have hello world, and here is the call to equals. I'm taking 2 strings, right? I got str, that's one of my strings. I've got this string that I'm passing in as an argument, as a parameter. That's the second string. And I'm asking, are those 2 equal? Is str equal to this? Here I have world, comma, hello. And I'm asking, is that equal to hello world? One thing I'd like you to note is it's the same characters, just out of order. What the string method is doing is this. It's basically this, right? We're just going through using a loop, comparing character to character. And the moment that we find 2 that aren't the same, they're not equal. Okay? So note that this is case sensitive, right? An A is not the same as an A. What about our program? Is it like that? What if I said pass 1, 2, 3 and then pass 1, 2, 3? We get a pass. Our passwords are different. Note that equals is case sensitive. So in the case of the equals method, it's the same thing. A lowercase a is not the same as an uppercase a. Here in this example, str has the contents hello world, but with a lowercase h, and ask is that the same thing as hello world with an uppercase h, and we get a false value. Okay, what that means is all of this, really I guess all of this, can actually just be reduced to one call to equals. I'm going to comment this out. And I'm actually going to comment out this if statement, which, by the way, I highlighted these lines, hit Control /, and that will comment or uncomment those lines. Line 28 here, I'm going to do the same thing, because simply put, we can say if the 2 passwords are equals using the equals method that already exists. The 2 strings in question are pass and check. This bit with the length, equals handles that too, right? It's actually going to do the exact same thing. This is the equals method basically. Before it checks to see are the characters the same, it's going to say, do they even have the same lengths? Because if they don't even have the same lengths, there's no reason to even check the characters. If pass.equals check. That's it. This one little method call does all this. If they're equal, we'll say that they are the same. If this is false, we'll skip to the else, and we'll do this instead. Let's test it. I got pass 1, 2, 3, pass 1, 2, 3. Those are the same. Note that this code that is commented out has no effect on my program. I can delete it if it makes you happy. Pass 1, 2, 3. What about pass 1, 2, 3, 4? Those are different. And I'm going to flip the order to see if that matters. And you see everything is happy so far. Last thing I'll test on is the uppercase thing. And notice that these are different. Same lengths. So we do end up testing to see are the characters the same. All right, I'm going to bring that back. Let's see what else they want us to do. When comparing strings, you should always use the equals method as opposed to the equals relational operator. Something I'll note is that the equals relational operator, that is saying pass equals check, this doesn't do what you want it to do. And I really just want to leave it at that. Note, it's not a syntax error, right? I can run this. But even IntelliJ has this highlighted as yellow. It's like, I don't think you want to do that. I'm just going to advise you not to do that. This is what I'm advising you to do. Always use the equals method when comparing strings. Really, any type of objects. I don't think we'll get into any other objects, really. But use the equals method, not the equals relational operator. These relational operators, use them with primitive data types. Your integers, your doubles, your booleans, your chars, right? We actually compared chars using a equals relational operator. But when it comes to objects, use the equals method. Okay. That brings us to indexOf, the second method that I want to talk about today. IndexOf returns the index, that is the first occurrence in which the specified string occurs in this string. Okay, if I just look at the signature, indexOf is in the string class. This takes a string, it returns an int. Let's see how it works using some examples. I have greeting with the contents hello world, and I want to know what is the index of E. Okay, this is going to return an integer, which I'm saving into a variable called word. That seems bad, but we're going to get a 1 out of that, right? I want to know at what index does E occur. Well, that's index 1. What about exclamation mark? Index 12. It's easy when we got it laid out. What about O? This one's a little bit harder. Why? Well, there's 2 of them. So what do you think? Before I reveal the solution, I'm going to jump back to this. It says the string method indexOf returns the index, the first occurrence in which the specified string occurs in this string. So when we have multiple letters, we're going to get the first occurrence going from left to right. Simply put, the way this method works is it uses a loop, and the moment that it finds what we're looking for, it stops. It returns. So that's how we get the first occurrence. But something that's important is the indexOf that we're talking about takes a string. So the examples I've been doing have only been one character, a string still technically, right? It's in double quotes, so it's technically a string, but just one character. Because we can pass in an entire string, it means we can look for multiple characters at the same time, right? Here we're looking for world inside of greeting. Well, world appears at index 7. Okay, one thing that's interesting is, am I going to get 7 or am I going to get 11? The answer here is 7. It is the index at which it occurs, right? If I was lining them up, again, this is just done by taking a loop and asking, are these 5 characters world? Are these 5 characters world? Are these 5 characters world? We're looking at 5 characters at a time, just moving it along. I think I can do a better visual. Where's my notepad at? Hello world. Right, this is what we're looking through, and what we're looking for is world. So I'm going to ask, are these 5 characters world? Are these 5 characters world? Are these? Right, we'll keep going. We're going to see coding bats, very similar to this. We would keep going until we got to this spot, and the spot that we're at is index 7. If the specified string cannot be found in this string, indexOf will return a -1. So this is kind of an error, not exactly. What if we're looking through the string for S? In this case, the string, hello world, doesn't have an S. In that case, we're going to return a -1. -1 is not a valid index, right? In theory, that's out of bounds. And so we can return it as kind of an indicator that it's not there. What if I was looking for spaghetti in hello world? Not there, -1. Okay, note that this is case sensitive. So if I were looking for a lowercase h in hello world, we're going to get a -1. If I was looking for lowercase world, still a -1. Okay, how does this help us? Well, often these accounts that you create online, they ask you to have special characters. So I want to modify password creator so that it prompts the user to re-enter his or her password if it does not contain one of the following characters: exclamation mark, question mark, $. There's lots of other special characters that you could possibly include in this, but the concept we'll get by looking at these three. So I'm going to flip back to password creator. I'm only going to really look at pass because it's a similar thing. We don't need to validate check because ultimately our equals will take care of that. All right, so we're checking the length. That's pretty good. That's one way to validate. I also want to check to see does it or does it not have the special character. So I'm going to do it in a separate loop, but realities are we want to combine these two loops. I'll let you think about why that matters. But this loop is checking the length. This loop is going to check, does it have a special character? Simply put, while it does not have one of the three special characters that we're looking for, we're going to prompt them to enter the password again. So let's do the prompting and all that first. I'm going to copy and paste the stuff from above, but instead of telling them it's too short, I'm going to say it should contain a special character, and then in parentheses put the ones that we're looking for: exclamation mark, question mark, $. Password should contain a special character, one of these three. Please enter a password, and then we get it again. So this is what we do if the password that they entered does not have one of the special characters. How do I know it doesn't have one of the special characters? Big hint. IndexOf. Right? If I look through a string using indexOf for something in particular, and I get back a -1, that means it wasn't there. Right? In this example, I'm looking through greeting for world. I get back a -1 because world's not there. So a -1 is the key here. A -1 will tell me that something is missing. So I'm going to say while pass dot index of exclamation mark. Right? We're going to look through pass. That's the user's password they're entering. We're looking for an exclamation mark. I'm going to get back an integer from this, which is why this is mad at me currently, because I'm saying like while some integer, while 7, while -1, which doesn't make any sense. While this is equal to -1. What is that saying? Yeah. So while, so we're going to look through our pass for an exclamation mark. And if we get back a -1, we would see that -1 is equal to -1, indicating that it is missing. So we'll tell them that it's missing. Let's try this out. Please enter a password. Pass 1 2 3. Notice that it is long enough, right? So in order for us to get to line 18, I had to get past this. So it's long enough, but it doesn't have a special character. Okay, so it's asking for a password again. Pass 1 2 3 4. No, still doesn't have it. Pass question marks. Okay, right now I'm looking for specifically an exclamation mark. Pass 1 2 3. Very excited. And now it's asking me to re-enter. We're down here at this check. Okay, and again, I'm not going to validate check because the equals will kind of effectively take care of that. Okay, you could validate check. Now I'm handling the exclamation mark. What about the other guys? Well, how about and pass.indexOf. I'm going to look for a question mark. If that gives me a -1, also a problem. And pass.indexOf $sign is equal to -1. There are much better strategies for accomplishing this in practice, but this is the gist. Right? I'm going to look through my password for an exclamation mark. If I get back a -1, that means it's missing. I'm going to look through it for a question mark. If I get back a -1, that means it's missing. If I look through it for a $sign and I get back a -1, that means it's missing. And I'm going to do all three of those. Let's test this out. I'm going to stop what I got going. I'm going to run it again. I'm going to say pass 1 2 3. Should contain a special character. Okay. Pass 1 2 3. Please re-enter. Pass 1 2 3. Passwords are the same. Okay, let's test for the $sign. I actually was not expecting to get this right. Note that I mentally did the correct solution first when I actually meant to try it out with or, right? Or is an option because one way to look at this is like, well, if the exclamation mark is missing or the question mark is missing or the $sign is missing, we have a problem. But take a look at what happens whenever we actually run that. Pass 1 2 3. Here it's saying I need a special character when I have one, right? But the way this is actually reading is if any of these are missing, then this triggers, right? It won't let us pass. It won't say that it's valid because something is missing, right? With the ands, the way it reads, if exclamation mark is missing and question mark is missing and $sign is missing, then it's invalid. Note that indexOf is overloaded. There's an alternate version. Take a look at this signature. Quickly identify what is different. It's going to be this char, right? The version that we were looking at takes in a string. Notice that I have double quotes around these bad boys. But we're saying it's overloaded, right? We now know of two methods that are overloaded, the other being substring. It's going to work the exact same, right? It's going to find the first occurrence, but if it can't find it, we're going to get back a -1. So here I'm looking for a capital W. We're going to get back a 7. Note that this is in single quotes. That makes it a char literal, not a string literal. And of course, this version is case sensitive. Again, it works the exact same as the other version of indexOf. This just gives you more flexibility. Right? To you, you're really not going to notice a difference. What it means is I can come in here and put single quotes around this, and it works. Right? I can put single quotes around this thing, and I can put single quotes around this one, and it's going to function the exact same way. That's all it means. This is a good thing for you. It is case sensitive, so if we were to look for a lowercase w, we'd get back a -1. Let's recap and get out of here. What is printed by the following code fragment? I have str with hello world. I have str2 with hello world. Now I'm going to know, are they equal? True. What about hello world and hello world? A lot less excited. We get back a false. What about hello world and hello world? Here we're going to get back false because equals is case sensitive. Okay, here we have a different string. Drillers are boring. And I want to know, what is the index of I? Why is this interesting? There's multiple I's, so which one am I getting? The first occurrence, that's this one. What index is that? 0, 1, 2. Okay, what about E? Should be this guy here, which is 3, 4, 5. Okay, what about R? We're looking for an entire string. So we're getting this little one right here. And again, as we talked about, it is where it begins. So if this was 5, this is 6, 7, 8, index 9. Space. Interesting one, right? Space is a character. We can do this. We're going to get the first space, which is right here. If this was 9, that's going to be index 8. Lowercase d. We're going to go through the whole thing, and remember that this is case sensitive. We'll get back a -1. What about a? Notice that it is in single quotes. It's a char. Doesn't really matter. We're going to get back the first a, which is right here, the only a. That's index 9 yet again. And that's going to do it. I'll see you in the next one.